We're going to be talking about solving or simplifying complex rational expressions in this video. So a complex rational expression is just a fancy way of saying you have a little fraction inside of a bigger fraction with these variables. So we're going to start simplifying this, and we have two ways to do this. The first is that we can get a common denominator between the numerator and the denominator, and then use the copy.flip method to cancel out the two fractions. And this is the most common way, but it's not the most efficient. The second way to approach this that we're going to discuss in this video is when you take the least common denominator between the numerator and denominator and multiply it to everything. This is going to immediately cancel out all of these little fractions in one step. So all we have to do is start by finding our LCD, our least common denominator, between every inner fraction. So in this case we have x plus 1, 2, and x plus 1. So our least common denominator between all of those is 2 times x plus 1. We don't have to include repeats. So we're going to take this 2 times x plus 1 and multiply it to the numerator and denominator of the large fraction. Another way to do this that might be easier to visualize is just multiply it to every term that's being added or subtracted. It's the same thing. And when we do this, we'll distribute this to every term in the numerator and every term in the denominator. And notice when we multiply it in the first term, I'm going to show this off to the side, but we have 2 over x plus 1 times this value, our LCD, 2 times x plus 1. If we put this 2 times x plus 1 over 1, we can see that there's a common factor of x plus 1 in the numerator and denominator. They're going to cancel each other out. And that's our goal here, to get rid of the fractions, because all we're left with is 2 times 2, which is 4, over this term is canceled. That means there's technically just a 1 there. So 1 times 1 is 1. 4 over 1 leaves us with 4. So this fraction is now just going to become 4. And we can do the same thing for all 4 of our terms here. This work off to the side isn't really necessary, but we'll keep showing it for this example. We have negative 3 times 2 times x plus 1. In this case, there is no fraction involved, so we can just multiply the negative 3 times 2 to give us minus 6 times x plus 1 over 5 over 2 times 2 times x plus 1 again. In this case, we do have a fraction. So we'll put this 2 times x plus 1 over 1 and cancel out these 2's just like we canceled out the x plus 1 factors, leaving us with 5 times x plus 1 all over 1. So again, the fraction is canceled. And finally, we have 7 over x plus 1 times 2 times x plus 1. Again, put this 2 times x plus 1 over 1, and we can cancel the common factor of x plus 1 from each of these terms, leaving us with 7 times 2 is 14 over 1, which again just leaves us with the 14. So we get a plus 14. Notice we've taken a large term that had 3 separate inner fractions, and in one step of multiplying the top and bottom of that fraction by 2 times the quantity of x plus 1, we've canceled out all of the little inner fractions, and now this is just a fraction, a rational expression that we can simplify. We'll start by distributing this -6 and distributing this 5 to get 4 minus 6x minus 6 over 5x plus 5 plus 14. Now we can combine like terms. We have a 4 minus 6 gives us -2. And I'll write this minus 6x to the left. It's always a good idea to order by exponents on your variables, so I'm putting the x first. And I'll put that over 5x plus 5 plus 14 gives us 5x plus 19 when we combine our like terms. And sometimes you'll see that you want to factor out the numerator, the common factors, but we're going to leave this just as it is and say that -6x minus 2 over 5x plus 19 is the simplified form of this complex rational expression. With that in mind, go ahead and take a moment, pause the video, and see if you can simplify this complex rational expression. Okay, so trying this together, the LCD in this case is x times 5, and then we have another x. We're not going to use a repeat. We don't need it, so we just get 5x. The only case where you would want to repeat is if you had something like x squared. You would need both of those x's. Not the case here. We're going to take this 5x and multiply it to the numerator and to the denominator. Distributing it in each case. In the first case, we get 5x times 5 over x. Well, the x's will cancel out, leaving us with 5 times 5 is 25. In the second case, we distribute to 4 over 5. The 5's will cancel out, leaving us with this x and this 4, so we get plus 4x. Over here, we have 5x times 2 gives us 10x. And here we have 5x times minus 1 over x. The x's will cancel out again, leaving us with 5 times -1 is minus 5. And again, just for good habit, we're going to we're going to reorder by exponent, which gives us 4x plus 25 over 10x minus 5. And there's nothing that can factor out of the numerator and denominator that will cancel. So we leave this just as it is, and we say 4x plus 25 over 10x minus 5 is a simplified form of this complex rational expression.